Most people fear one thing when they fly, that if an engine fails, the airplane will plummet from the sky. It's a natural fear. After all, engines feel like the heart of flight, powerful, vital, irreplaceable. Yet the truth is far more fascinating than fear itself. Aviation is not built on intuition. It is built on physics, engineering, and meticulous planning. Every commercial airplane is designed with redundancy in mind. Every system, every control, every calculation considers the possibility of failure. Losing an engine is not a catastrophe. It is a scenario that is expected, tested, and trained for. Pilots practice engine failure repeatedly, both in simulators and in controlled conditions, so that what seems terrifying to passengers is a routine procedure in the cockpit. But even training only tells half the story. The real marvel lies in the design of the airplane itself. Engines do not lift planes. They generate thrust, the forward motion needed for flight. Lift comes entirely from the wings. Air flowing over and under the wings creates a pressure difference strong enough to counteract gravity. Even with only one engine running, as long as the plane maintains speed, the wings continue to carry the aircraft safely through the sky. Consider takeoff, the moment when danger is at its highest. Speed is low, altitude is limited, and every second matters. Losing an engine at this stage could feel catastrophic, but the aircraft is engineered to survive. Modern planes are tested rigorously to ensure that even in the worst-case scenario, they can continue climbing and even land safely. This is the hidden genius of aviation. Every component is calculated, every system redundant, every procedure precise. Engineers anticipate failure, and pilots respond calmly. Even in moments that seem perilous, the combination of human skill and engineering ensures that the flight remains safe. Flying is a dance of physics, precision, and human decision-making. When an engine fails, the remaining engine, the wings, and the pilot's adjustments work together like a well-trained orchestra. If one element falters, the others compensate, maintaining balance and momentum. The plane continues forward, seemingly effortlessly, even against the odds. Yet passengers rarely notice. The safety, the engineering, and the training operate quietly behind the scenes, invisible but absolute. Understanding this transforms fear into awe. Every flight becomes not just a journey through the sky, but a demonstration of human ingenuity, a testament to our ability to predict, plan, and overcome. Even in the most dramatic situations, there is no panic, only precision, calculation, and control. Every landing, every climb, every smooth cruise is a story of anticipation and preparation. It is a reminder that fear often arises from misunderstanding, and understanding turns fear into confidence. The moment an engine fails, the cockpit transforms into a controlled storm. Warning lights flash, alarms sound, and the hum of the aircraft shifts. To the untrained eye, it may seem like panic is inevitable. But for pilots, this is a scenario they have rehearsed countless times, down to every movement and every decision. The first instinct is always calm. Training ingrains a sequence of actions so deeply that even under pressure, the response is automatic. Hands move to the controls, eyes scan the instruments, and the brain processes multiple streams of information simultaneously. Every dial, every gauge, every warning light has meaning. Nothing is ignored, and nothing is accidental. Airplanes are designed to support this human precision. When one engine fails, the remaining engine, combined with automated systems, begins compensating. Flight computers adjust thrust, stabilize flight, and help maintain altitude. The plane itself becomes an ally, executing maneuvers that would be nearly impossible by human hands alone. while the pilots direct, monitor, and adjust with fine precision. Step by step, the pilots follow a carefully crafted procedure. They identify the failed engine, adjust the thrust on the working engine, and make minor corrections to the flight path. They bank slightly, maintain speed, and keep the aircraft balanced. Communication is constant between co-pilots, with air traffic control, and with onboard systems. Every command is deliberate. Every adjustment is calculated. Even during takeoff, the most critical phase of flight, this choreography unfolds flawlessly. The plane climbs steadily, defying what instinct might tell a passenger is possible. The remaining engine pushes forward, the wings continue to generate lift, and the aircraft remains in perfect harmony. What seems like chaos from the outside is, inside the cockpit, a display of discipline, training, and trust in engineering. Human skill and machine capability merge. The pilot's hands, guided by experience, work in perfect sync with the aircraft's systems. Redundant controls, backup instruments, and automated checks ensure that even if something goes wrong, there are layers of safety. Every failure is anticipated. Every contingency has a solution. Passengers may never see this intricate dance. They only feel the calm voice of the captain, the steady hum of the engines, and the smooth continuation of the flight. Yet, behind the scenes, there is a silent symphony of motion, adjustment, and precision. This is what allows airplanes to navigate situations that might seem impossible from the outside. Understanding the cockpit's response to engine failure reveals the elegance of aviation. It is not luck that keeps planes flying, nor chance that prevents disaster. It is a combination of meticulous design, rigorous training, and split-second human decision-making. In the face of what seems like catastrophe, there is order, skill, and confidence. Every successful recovery is a testament to preparation. Every smooth flight is proof that the impossible is routine in the world of aviation. And for those who know the mechanics, the procedures, and the training, the sky is not a place of fear. It is a place of mastery. Even with a skilled pilot at the controls, it is the aircraft itself that performs the most remarkable feats during an engine failure. Modern airplanes are not merely machines. They are marvels of engineering, designed to anticipate failure and respond with precision that rivals the most disciplined human mind. Every system in a commercial aircraft is built with redundancy. Hydraulic lines, electrical circuits, flight controls, all are duplicated or even triplicated. If one system fails, another takes over without hesitation. This is not luck. It is deliberate design, a safety net woven into every inch of the airplane. Consider the flight control systems. In the event of an engine failure, minor adjustments are continuously required to maintain balance and altitude. The aircraft automatically aids the pilot, compensating for yaw and roll, while the wings and control surfaces distribute lift efficiently. Sensors feed real-time information to flight computers, allowing instantaneous corrections that are far faster than any human reflex. Even fuel management plays a crucial role. Jets are equipped with complex fuel transfer systems that ensure weight distribution remains optimal. If one engine stops, fuel from specific tanks can be redirected to maintain balance and prevent instability. The aircraft is continuously adjusting itself, performing thousands of micro-corrections in a matter of seconds, all while carrying hundreds of passengers safely overhead. Landing gear, flaps, and thrust reversers are all part of the contingency planning. Every component is tested under extreme conditions to guarantee performance when it is most needed. From the tiniest hydraulic actuator to the massive engines themselves, every element is synchronized to keep the airplane in controlled flight. Beyond the hardware, software plays a critical role. Flight management systems constantly monitor the aircraft's performance, predicting outcomes and alerting pilots to the best course of action. Some systems even provide automatic adjustments, taking the load off human operators and allowing them to focus on strategy and communication. This seamless interaction between human skill and machine capability is what makes engine failures survivable. It is a choreography of physics, engineering, and experience. While passengers may feel only a slight vibration or hear a subtle change in engine tone, inside the cockpit and across the aircraft, a complex ballet of systems is unfolding. It is here that aviation's genius is most apparent. The airplane is built not to simply continue flying, but to recover, adapt, and maintain safety. What might seem like chaos is, in fact, meticulously orchestrated. Every redundancy, every check, every engineered safeguard ensures that the impossible becomes routine. Understanding the depth of these systems transforms fear into appreciation. Passengers are protected not only by the skill of the pilots, but by the invisible intelligence embedded within the aircraft itself. In moments of potential disaster, there is no panic. There is calculation, precision, and resilience. Every successful flight after an engine failure is a testament to this incredible engineering. Every smooth landing, every steady climb, every cruise at altitude is proof that the aircraft's systems are not merely supporting flight. They are actively ensuring survival. In the skies, what seems impossible is actually commonplace, and it is the combination of human expertise and technological mastery that allows millions to soar safely every single day. Above the clouds, the airplane glides with effortless precision. Passengers rarely see the invisible layers of skill, calculation, and engineering that keep them safe. Yet every moment of this flight is a testament to human ingenuity, to the fusion of mind, machine, and meticulous planning. Flying is more than mechanics. It is a dance of trust. Passengers trust the pilots, the systems, and the design of the aircraft itself. Pilots trust the instruments, the procedures, and the engineering that allows them to make split-second decisions. And the aircraft, in turn, executes each command flawlessly, as if anticipating every movement before it occurs. Every takeoff, every climb, every turn is a delicate balance of forces, physics made tangible. The wind, the lift, the thrust, and the weight all converge in perfect harmony. Even when an engine fails, this symphony continues. The airplane adjusts, the pilots guide, and safety remains absolute. What seems miraculous to those on board is, in reality, the product of decades of study, testing, and refinement. Consider the sheer scale of what is happening. Hundreds of passengers, thousands of pounds of equipment, and tons of fuel all move together through the sky. Yet this colossal system operates as a single cohesive organism. One element fails, and the others compensate. One challenge arises, and the aircraft adapts. It is a seamless collaboration between man and machine, calculated yet breathtaking in its execution. This is the essence of aviation. Mastery hidden in plain sight. Fear transforms into confidence, awe, and wonder. Every successful flight is proof that meticulous preparation conquers uncertainty. Every smooth landing after turbulence, every climb after engine failure, every controlled descent through clouds is a quiet victory for engineering and human skill. Understanding this transforms the way we see flight. It is not just transportation. It is a story of resilience, precision, and trust. The sky becomes a stage where physics, design, and human expertise perform together, creating a spectacle of mastery. And perhaps most importantly, it reminds us that fear is often born from misunderstanding. When we understand the systems, the training, and the science, Fear becomes appreciation, and uncertainty becomes admiration. Flying is not just safe, it is extraordinary. Every journey through the skies is a reminder that what appears impossible is routine for those who have designed, built, and mastered these machines. And in that realization lies not only safety, but awe, the profound beauty of human achievement taking flight. As we gaze at the skies, remember, aviation isn't just about planes, it's about curiosity, courage, and the thrill of exploring the unknown. Every takeoff sparks innovation. Every flight tells a story of precision and passion. The sky isn't the limit. It's just the beginning. That's all for now. I've been your aviation guide. Until next time, keep looking up, stay inspired, and take care.